number. Now, tonight's webinar is on statistics. Now, before we get started on how to do these statistics on TI-Nspire, I just want to talk for a moment about how powerful data is in today's world. I've always been a calculus sort of a person, but statistics is becoming more and more influential over what's happening in the world. As an example, some of the biggest data collection services are not those produced by the government authorities, rather companies such as Google and YouTube and various other web searching platforms. So, for example, Google has more than 1 billion searches completed every day. It's something like 1,600 trillion searches on Google last year alone. So huge amounts of data can be collected. Now, one of the interesting bits of data that Google collected at some stage was looking at trends in the common cold, that is, the flu. So they looked at how frequently people were searching for terms like sore throat, mucus, and so on. Charming, but never mind. And then they looked at the national health data and found that they could anticipate an outbreak of the flu 7 days in advance of the actual outbreak, just by tracking those search criteria. And they can correlate it, which brings me to my next point, is this little tool called Google Correlate. So that's up on your screen now, and if you've never seen it before, it's a bit of fun. You can type in a search category and see what other things are searched at the same time or similar frequency at the same time of year. So an exam, for example, then if I type in exam, and you'll notice I've searched over here on Australia, other people will search for exams at the same time, past exams, final exam, exam time. We could maybe search maths exam and see what other things correlate with that. Further maths. So that might be an interesting stat for some teachers out there, and that is when students are searching for the word maths exam, there's an almost perfect correlation for those students searching for further maths around the same time. And 3rd of November. So I'm guessing that the further maths, or there was a maths exam on the 3rd of November. That would have been for last year, or perhaps a period of years. So just a little adjunct to our session tonight to show you that the amount of data that is being collected is really quite large, and it's becoming more and more influential in terms of how the world is being run and what's being watched, if you like, because what you type in the search engine is not really confidential anymore. All right, so without any further ado, I'm going to pass over to Rodney Anderson, who's going to kick us off with just some introductory stuff and then get into some really cool things that you can do with TI-Nspire and data collection. Are you there, Rodney?
Yes, I am. Thank you, Peter. Thank you for the introduction there. So with tonight's session with myself and Russell, I'm going to do a few simulations involving TI-Nspire and show the applications and what we can do with the data. And Russell's going to continue on with that and maybe do a few other things as well. So it's a lot to cover tonight and see how we go. There's maybe a little bit of repetition we've used in the past, last year in some of the webinars, but as I said, we'd like to do some simulations because the calculator can simulate data, and then websites contain lots of data, and how do we collect the data from websites and how do we transfer it to the calculator or the computer software? One of the things that we can do. So first of all, I might like to generate a list of 20 numbers randomly generated from 1 to 10. So what I can do is actually in a listen spreadsheet, what I could do is actually press menu, in data, select random, and then I can actually select integer. And I want to select numbers from 1 to 10, and I'd like to have a sample of 20. And when I press enter, I have my 20 numbers randomly generated. So what I could do, like all things in lesson spreadsheets, we should always label our columns. So I'm just going to call this data to start with. So what can we do with this data? So let's have a look. Now, to graph data or other things, a few ways of doing that. What you could do, you could select Home and select Data and Statistics. And there we have our data ready to go, what we can do with it. So what I could do is come down to here, click on it, add the variable. I called it data, and there we have our dot plot of all our data. Then I'd like to actually change that graph. So what I can do is select Menu, select Plot Type, and let's have a look. We could convert that data to a box plot, histogram, and normal probability plot. So let's select histogram firstly. Very nice. And as I'm using the teacher edition software, I may actually select this icon up here, which is the same thing as pressing the menu icon on the handheld. So there we are there. So I could actually select and convert it to a box plot. There we have it. So we have our 5-number summary with the box plot. So if I actually go back to my list and spreadsheet, I may wish to select another 20 random numbers. So I could come across into the second column and do the same thing again. I can type in equals, and as you may be aware, as we've got the instruction or the command random integer, I could type that in, but in the process I can select Menu, Data, Random Integer, and do the same thing, 1, 20, my apologies, 10, 20, and there is my second set of numbers. I might call this second list. So as before, I select the home keypad. What I like doing all the time to insert another application, I like using Control I for insert, and select a data and statistics page. And what I could do here is the same thing again, select second, and there I have my dot plot. Now, another thing that students like to see, and it's the power of the Nspire with moving data, is just suppose I wanted to find the mean of these points. We've covered this in the past in previous webinars. What I could do actually now is select Menu, Analyze, Plot Value. And what I could do is find the average of that data. So I can just type in mean, select the var key, the variable key, and select second, and then press enter. And there is my average. Now, I know I've selected random numbers from 1 to 10, but if I actually grab the outer point, I haven't got any outliers here, but if I grab this value here and move it, it just reinforces what happens to the average when I do move it and move it along. So I haven't actually moved it along, so I can't actually do it because I've generated. My apologies for that. Now, that's with generating random numbers. Now, a lot of the time we can actually collect data from websites. Now, there's several websites, or many websites existed to actually generate data. Some of the ones that I've seen in the past that you may have seen are Census of School. Now, even last year, the Census of School concluded the government funding end of last year. It's still there, and hopefully in the future will continue to go. There are pre-prepared samples for calculators, and some are prepared data. They've cleaned it up, and some of the data's not clean, so it's got errors in the data. So what we can do here is on that website, and you'll see it up here, the website, I can actually click into prepared samples. Now what this is actually samples that have actually been cleaned up and ready for students to use. So we come down to here and select what type of data. So what I might do is actually collect some numerical data, and the last time they did it was 2013, and I might grab the first set of data. And as you see there, it's actually an Excel document. I'm going to open the Excel document. And I'm going to select the first page. And you'll see there's a whole lot of data that's been collected in this sample, and it's up to you with your class or students what you want to analyse. I may actually wish to analyse traditional height and belly button distance. So what I can do, it's been actually put into an Excel spreadsheet, so I can actually, for example, select the first 25 students, copy that, Control C. I'm going to come back to my TI-Nspire. I'm actually going to add a new document. I'm going to add a listen spreadsheet, and I'm going to paste it in there. Oops, what have I done wrong?
That's a good demonstration of the fact that you can't have the cursor in that cell.
That's what I've done wrong. Yes, a good demonstration. I clicked
it is a very common thing to do.
Yes, often in the class I do that sometimes, and I just got to remind myself of that fact with the cursor being there. So as you saw there, the first column was height, and label it as height, and the second column was belly button. I'll just call it belly button. Here we go. And so I have 25 student samples of their data, so I may wish to actually plot their a dot plot of their height. So I will actually just go Control I and add another data and statistics application, and I'm going to click and add their height. So we have their dot plot, and I want to convert that to a box and whisker plot. So plot type, box plot, and there we have it there. So then you can talk to the students, what does this actually mean here? And then we can talk about relation to outliers, and you can actually clean the data up, or maybe check the data, so we can look at that. Now, as most schools and most states like to have parallel box and whisker plots, so I want to add the belly button height or belly button distance for this one. So there are two ways of doing that. One is I could come down to here and right click and add next variable. I click onto there, and then I can actually select the belly button, and there we are. We have the parallel box and whisker plots. Another way, if I just undo that, so we do it all again, we've got our box and whisker plot. What I can do is go to the menu, go into plot properties, and then add X variable. So it's up to the user, student or teacher how you want to add another box and whisker plot, and there you go, you actually have your parallel box and whisker plots. Now, as with randomly generated numbers and other data, what I've shown in the past, you may have seen, is the ABC Splash websites. And what you can do, you can have your students create their own data, collect their own data, or maybe you can use the data from the actual census. So it's, as you see on the website, it's collected in 2011 Australian Census. So what you could do, you could click View a Story, and of the actual census data they've actually taken, you may wish to select population, age and gender, which most of the time I look at, so I might select into here. So you can see that across Australia, you'll see how many males and females are there within the Australia as we go along. So as we're getting older, the number of people is reducing, and you can actually see the data as you go through. Is that the baby
boomers you just went over there, Rodney, that little bump?
Yes. They're spending this children's inheritance and the grandchildren's inheritance. So they're going on long holidays. Won't mention any names. So what you could do is you actually select a certain state and say which one's got a state that's actually good for healthy living. So, for example, if I select Queensland.
Here we go. Here we go.
Let's have a look. Go to Victoria. Let's have a look where they look at Ooh, it's a lot more. You'll notice there was a bit of a bump there. But as I am in Victoria at the moment, what you can do, you can actually collect the data.
Now that bump in Queensland in the older age group, Rodney, that's just the Victorians coming north to live up in your beautiful weather up there.
Yeah, that could be it. Yes, that could be it. So, and you'll see that what you could do is actually have the data table, and you could actually highlight this and copy it to Excel. Now, the very important thing is if I do it now, the phone here, and highlight this data, I might want to copy that data and then go to my Excel documents and open a new document. And if I just paste it, so I was very quick in actually copying it, you'll notice that this in Excel we have commas in this column, and what we should do is actually always check that our numbers do not have the columns. So what you can do is right-click and format the cells, come into number, and you get rid of the decimal places. We've got general numbers, we click OK. Then we've actually got numbers that can be copied straight into the TI-Nspire listen spreadsheet with those numbers. So it's very important to have, if you have your data in an Excel spreadsheet, that they do not have a lot of commas here, and you check the numbers. So getting back to the TI-Nspire, we have our data, and we've actually collected data before from the website. We've copied it in. You've got to be very careful when you click into a cell that it will not like that, so you've got to be very careful copying the data. And with the data, it's up to you where you want to use the data. So random integers, you can generate it. Throughout the rest of this webinar, Russell's going to look at types of random generation numbers, looking at other websites, and I think I'll finish up there with that situation.
Before you do, can I get you to do me a favour? And hopefully I'm not stepping on Russell's toes here. Can you do a scatter plot of height versus belly button height for me? And I know we'd done this on an earlier webinar, but it is one of my favourites in terms of seeing that trend in there.
So I've actually got a. You want me to go through data and statistics?
Yeah, data and statistics is good.
Okay,
yeah.
So Peter said height versus belly button. So
that's it.
Height versus belly button.
That's it, and then students can obviously... Now, it's interesting because I do a similar activity where I have students guess the age of people based on their photographs, and depending on which way you plot this, you can ask students about those points that are sitting well and truly outside our general trend. There's a significant general trend there, and without, like what Rodney's doing now is highlighting them, and this encourages students to quote certain values, or at least to go in and explore the data, because one might suspect their belly button is unusually high or is unusually low. And interpreting the graph when you flip those variables around and have them perhaps the opposite way to what they might expect, it means they've got to do a bit more work in understanding what that data is showing, because it's not uncommon for us to see data misrepresented in newspaper articles, for example, where it's not really plotted the way we'd expect. The other thing I wanted to highlight about that data you had up there, Rodney, if you can go back to the spreadsheet where all the data is residing from the ABS website, just on your spreadsheet.
On the spreadsheet, here we go.
The census one.
Oh, that was the census one. That was the first one. There we go.
The other thing that's really important, I mean, we're looking at belly button height versus the actual person's height. Even a simple challenge of getting students to explore, well, which of these variables correlate the best, which is kind of like that Google Correlate website, where you can say which ones of these variables are likely to correlate. So perhaps their year of birth and the number of hours spent doing homework. You might hope that that was an upward trend as the child gets older. It's not always the case. And finding the best correlation, what has got the strongest correlation of all of them. Of course, if there's some dirty data in there, that doesn't always help. But we can see later on how that might be removed in the case of a student not really measuring their belly button height correctly. There's another common one which is arm span, and there's usually a lot of them that are extraordinarily low because the students are at arm span as the length of one arm, not from fingertip to fingertip.
Mm-hmm. That's correct.
That's
Rodney, was that sample from the cleaned data?
That was from the cleaned data, that one there with the website. So what I did before is actually with the Census at School, you'll see data prepared samples page, and I went through 2013 set 1 to 10. So you'll see there's a lot of data there with the actual census website. If I go back to the actual home page there, you'll see prepared samples. I only went through numerical, there's categorical. There's a lot more data we can actually do that. If I go back again, we have data for calculators, and as Russell and Peter have mentioned, that there's data in there that students have made errors or misinterpretation of questions and what they've done.
Now, the interesting thing there, Rodney, on your scatter plot that you had height versus belly button was those values were not considered by the ABS as outliers.
No.
They might be people without legs, Russell.
Yeah,
That's right.
As I said, there may be people in wheelchairs, you just never know.
Because they've included that in the clean data.
So like all things with data, we've always got to be careful having to whether we generate it ourselves with our students in class or go to websites and check with websites and what we're doing, because personally, as a teacher and as a person reading newspapers, someone says, according to data, and you sit back and go, where do they get the data from? How do they average it? A good activity I use in my class with my girls, I talk about the average bolero size, which is their top part of their uniform. Oh, they say they're a size 12 or a size 14. What does that really mean? Now we're talking about versus mode versus the mean, and talking about data. So it's a very important thing to look at data. So just conscious of the time, so what I might do is actually stop what I'm doing. Any other things I should look at with my data, Peter or Russell? Both there?
No, I think you've done a good job, and I'll transfer over to Russell.
I'll let you do that.
Yep, and while we're just sending that screen across to Russell, I just wanted to quote some other interesting data or stats that I picked up from the web, that in 2009 the most popular sport amongst children was swimming at 19%, followed by soccer at 13%, and then finally the AFL at 9%. I was quite surprised that swimming was the most popular sport amongst children. It didn't define children, of course. And the other one, which I know Rodney is going to enjoy, this is more of just an interesting fact as opposed to a statistic, that Queensland is 5 times the size of Japan and 2.5 times the size of Texas. Just a good one there for you, Rodney. I thought you might enjoy that one.
And Western Australia likewise too.
That's it. It's second largest state in Australia indeed, in terms of area anyway. All right, so it looks like we've got you up on board there, Russell, so it's over to you.
Peter? So is there more longhorn cattle in Rockhampton than in Texas, Peter?
That I don't know, Russell. I can Google that while you're doing your presentation if you like, but I'm not sure and I'd know where to start.
Okay, thanks for that. Thanks, Rodney. Just a couple of other websites that you can get some nice data from. Is one of the nice ones there that throws up some confusing statistics is the water storages. So if you went to, or just search Melbourne water and the storages, so there is a link here. We'll put this information on the web later, but this is just a short part of it. Now, Rodney showed you how to take the data from the web, particularly from Excel, just copying it, making sure that you've got no commas in your data. You can either go to Format, or you can just do it from your home and then just go to Number, which you'll find across the top row, and just choose General from there, and that will convert the highlighted columns without commas. But for something like this, probably just manual entry is all that you'll need. So this is just a few of the dams with Melbourne water. But what I'm going to show you here is an example that I did for Southern water, and I haven't actually worked through all of that too closely. So there was only half a dozen or so reservoirs here. And I've just taken two columns of data. The current capacity, this was at the start of January of this year, and there's the capacity when full. So if you gave that information to the students and asked them to come up with Well, what is the percentage of fullness, as it were, of the reservoirs, of the dams? So how would the students approach it? Would they just go and add up the current capacity and divide it by the capacity when full and multiply by 100%? Or would they have to use some other way of doing it? So what I've done here is just had a little bit of a look at what we've got, and you will notice that if you are doing this with your students, choose the document preview, the one that looks like a computer. So you'll see my cursor up in the right-hand corner there. So if you choose that, choose the computer view so you can see more of the spreadsheet. And if you find that you do have plenty of room, you can actually increase the boldness down the bottom here. That will bring it up larger, but you'll see less. So the capacity is the full capacity. The current one is there. So if I just added all of these up and used them as the denominator, added all of those up and used them as the numerator, multiplied by 100%, what sort of value would I get? Alternatively, you have the option of working out the percent full of each one and then working out the average of this. So you've got a couple of ways of working out the average. We've got the weighted average. So there are lots and lots of opportunities for you to just take some simple statistics like this, a nice little task to give to the students, and get them to justify how they've come up with their values. So it doesn't have to be a huge task, just manual entry, and they can just work from it. Going on the website, you can use Melbourne Water. There are a few more storages there. This one here, as I said, is Southern Water. You can, if you're in various other states, you can just go on and check the water storages in your states, or regions if you wish. So something that's just nice and easy to, basically to work with there.
Just before you jump off that one, Russell, I have a question without notice, and I know you love me doing this to you. See the data that you've got in that word table there? So just scroll up a little bit. You had all the values typed in. Now I know I see data in PDF. Sometimes it comes with a textbook and so on. And I know teachers sit there painstakingly copying it out and putting it into a file, or they get the students to do it. Can you actually highlight and copy the information in that table?
Which one is it, Peter?
Yeah.
I'm in Word here.
Yep, so that'll do.
So I can just highlight that.
Yep.
And I can just copy that.
And if you go into Inspire, will it copy
and I can just
Inspire, I wonder?
Just a new Inspire. And once again, as I said, don't click in here, just leave it blue, and you can paste the values in. So you just need to make sure that you don't actually have your cursor active in there, just needs to be blue highlighted. And then, of course, we can just go up and...
commas on the thousands.
Yeah, if you have got the commas, you need to make sure that they've been removed.
Yeah.
And an interesting thing here, I was actually going to bring it up a little bit later, but I'll just name these. These here are the reservoirs, their names, and this one here is basically when they're full, and this one here was their current. I was actually going to show this later on, but I'll just show it at this stage here. If we now insert, and on the computer software you can see that we can insert from up here. You'll also notice if you are on the computer view here, and I'm just on the calculator view, if you're on the computer view here, a lot of your symbols up here don't work, so you've actually got to use it from there. So if you're in a computer view here, you'll really need to use the document tools, either this one here that Rodney mentioned earlier, or the one over here. Some of these will work, but these tabs up here don't if you're in computer view. So I'm going to insert now a data and statistics page. Now this looks pretty miserable here. A lot of people complain about this page. We can click on this and change it to any of our list names. Generally, it will be the first one that's going to be sitting there. Now, this is a very, very useful page. It is not just there for fun. It's not there just to annoy you or your students. what you'll need to do here, if you had a country in column A, and then different countries, and then you had all the other information, say you had 6 or 7 other lists of data about GDP, amount of CO2 emission, birth rate and whatever, you can just click on the country. In this case, I'm going to click on a reservoir. I'm going to click on this one here. If I just moused on it, it tells me all the information, but I'm going to click on that because now I'm going to just put this into just reservoirs, and I might just go up here and add a Y summary list and say when they're full. You'll notice that it is highlighted. So it's very, very useful if you're using numerical data where you actually don't have the names. So if you're doing a country and you want to do CO2 of all the countries versus GDP of all the countries, if you highlight, say, Australia on that first page, it will be highlighted in a box plot for Australia, the position of Australia, by various data, it will be highlighted there. Easy to get rid of it. You just click on the outside and you've removed it. But it is a very, very useful page to have. I'll just remove that one now. So that's something that you can just work on, that one there. It's quite a nice little worksheet, a little task for the students to do. Tell them to come up with the answers. You know, what answer would you give if you were presenting it to the media about what percentage of water is in storage, still held in storage? Whether you can have a shower tomorrow or not. Very, very important. Another really nice one is your speeding fines. And of course, we know they're only there not to save lives as such, but they're there to make money. And nice proof of that is if you go to that website, and if we just have a look at that website there, and this one here, Office of State Revenue, we have these in all the states. I've just chosen New South Wales here because if they're finding them there, hopefully they're not finding this in these other states. So I've just chosen this police issued speeding offences. You'll notice it opens up as an Excel spreadsheet, and as Rodney showed you before, very, very easy for us to copy that data. So if we have a look at the speeding fines there, so there it is there from the website. Once again, here, I'm not going to choose this one here because it's only half the year. So I'm going to choose that one there. I'm just going to go across here and take these. Look at this nice amount of money they're making, $5.5 million in June. They've made some nice money, $69 million for the year in speeding fines. So I'm going to copy that, and it'd be nice if I could just go and paste that into our listener spreadsheet, but notice the commas there. Rodney mentioned it before. I'm just going to open up a brand new Excel spreadsheet.
Does Joe Hockey know about these stats here, Russell?
Sorry?
I noticed Joe Hockey's not watching our webinar tonight, but I wonder if he knows about the revenue being raised out of these fines.
Oh, gee. Yeah, just get some more in there. So what we need to do is, Rodney said, just highlight that column there. I do it in a slightly different way. I just make sure that I choose the Home tab, and over here is Number, and I just click on that and choose General, and that will remove them for you. So now we've got that information, we can just copy it. Again, just go into our normal, I'll just make one of these up, just get rid of that. Just open up a new document and listener spreadsheets, and we can just paste the data in. So there's the information there. I've already collected them over 2 or 3 years, so we'll just have a bit of a quick look at what we can do with that data. So what I need to do here is just choose my speed one. So there's one already made up, month, and so on. How can we plot this information? Now, when you look at that, you would think a time series would be nice. We have some limitations doing time series just from this directly. So let's insert a page, and I'm going to insert a data statistics page. click down here, and I'm going to put month. Now, going up here, if I click on there and just choose a variable, what I'm trying to do there is playing around with kind of bivariate, but of course we've got categorical on the bottom, and we're not going to get very far by doing that. So we'll just put those up there. We can't join those dots, and you'll also notice that this is in alphabetical order. So I'm going to undo that. And rather than just clicking and adding a variable, I'm going to add a summary list, which is like a frequency. So I can right mouse click on this, or as Rodney also mentioned, you can go back to your menu, plot properties, and I'm now going to add a Y summary list this time. And I'm going to choose that one. I'm going to go back to it again, but I'll just do it this other way. Right mouse click, I'm going to add a summary list. I'm going to add that one. And I'm going to add another summary list, and there it is there. So you can see that it's not a line graph, but it's very, very interesting. And I was just having a talk with Peter and Rodney earlier, were the people who are running the cameras or doing all the speeding fines, were they asleep then? Or was there a petrol shortage? Or was the computer system out? We don't know. But you can look at trends here just from this sort of information. So here we're making sure we're adding a summary list, which is basically a frequency, using a frequency table for that. So once again, all states have that sort of information for us. So if I just go back now and just continue on, so you can see what we've done there. I can, by the way, just put month 1, 2, 3, 4, 5, and then I can make it into a plot that you may wish to have. So, I mean, if we want to go back to that one again, I can insert a data and statistics page. Down here, I've actually got them numbered as financial months, 1, 2, 3, 4, through to 12. So I've given them numbers. Now I can treat it in this format. And I do have the option now of connecting the data points. I can go here and add a Y variable, and I can just go through and add the rest. So I can do it in that time series format, but I must put them in months numbered rather than the category month. So hopefully that gives you some clues of how to approach those sorts of problems. Now, another very, very nice site is the World Bank. So just type in World Bank data. Once again, there's an actual website that you've got there. And this here is just some information that I've actually typed in here, some of this, or I've actually copied and pasted it into an Excel spreadsheet because it's not always in the view that you want it. So what I'll have a look at here is something from the World Bank. It is basically just some information there that I've chosen, and this gives me the countries, and it also gives me the male life expectancy of males, life expectancy of the females. So once again, I can just pinch that data there. I'll just take some of those from there, just copy that, take it into our spreadsheet, and if I just create a new one, I'll just make it a computer size here, add a list and spreadsheet, and just paste in there. So we've got that information there. So just very, very quickly, I'll just show you why it's important to have that first page. This one here was, I think, male and female. It's looking a bit sad there, isn't it, for males? And this one here is percentage of females in the population. So I'll just call it percentage for no other particular reason. So if I now insert a data and statistics page, this becomes very, very important now, because if we choose a country, and if Australia was there, it'd be nice and easy, but it's a bit hard to find for me. Where's Australia hiding? We might not have even got it. Yes, we have got Australia there. I'll just go back, and we'll just pick up Australia, there it is there. I'll just highlight Australia there. Mousing over will give me all the information. Females, 2012, live an extra 4 years, but we don't have to wait as long to go to the restroom, so we probably gain those 4 years. Anyway, I'll just get rid of that, and I'll just select Australia by itself. Now, when I go down here and I do male and female, we can see out of that group that I selected. Now, of course, that's not all, all the countries or even the major countries, first world countries. You can see out of the first, whatever, 20 or 30 of the countries that we've chosen from that list, Australia is a very, very good winner up here. So that's the advantage of using that first page to your advantage. You can locate your country at any time, and if I change this into, say, just remove this one here, so I'll just remove that Y variable, and if I change this now, I just need to go back here because I have clicked out of this. I'll just go back again and just choose, let's just say we're from Belgium. So choose Belgium. I would just go here and put female. So there's where Belgium is sitting. I'm now going to change this into a box plot. And you can see that it allows you to see where you belong, even in straight numerical data. So a very, very nice little thing to have. So leaving that one alone, we'll just go back. And also another one here, this website is also a very, very nice one. If you just type in hdr.undp, it will take you to a nice website to give you a lot of world data comparisons. So I'll just leave that on the screen for a little while so you can have a look or write it down.
Russell, sorry to interrupt, a good website actually we've talked in the past is gapminder.org.
Yep.
That's a wonderful site for data, isn't it?
It is. Very, very commonly used, that one as well. Okay, the next thing we want to have a look at is how do we generate sample data? And I'll just show a couple of screens here and then we'll actually do it on the calculator. When you are doing random samples, make sure that you do a rand seed first. You only need to do this once unless you put a new operating system on it. Now, the reason for that is that the random generator basically has to start somewhere, and the original operating system sets it at a certain value, and everyone will get the same value, excuse me, when they start off. Now, once you've started a random seed, I normally just ask students to use the last 4 digits of their phone number. If you want to be silly and get the same answers, just ask the kids to use the first 4 digits of their landline, and they'll still get all the same numbers. But it is important to do that. And if you generate some data and you record it somewhere, as a teacher, you record it and think, oh, gosh, I forgot to get a screenshot of that, and you've done all this other work based on that. Undoing will not take you back. So setting a rand seed again with those digits will not get you the same random generated numbers. So you can't go back. So menu, probability, random, and seed. So let's just do a random binomial. There, I'll just get that one up and running for you. So we're just using random binomial. So I'll just insert. And basically, we can just do these on the calculator, or we can actually do them in the listen spreadsheet. Generally, it's easier to do it on the calculator page. So I'll just do a rand seed. Since I'm on the computer, I'm just actually going to type in rand seed. Notice that that is all italics. As soon as I press a D there, it becomes upright. That means it is a calculator defined or a TI-Nspire defined word. So we're just going to reinsert a space. If I pasted that from the menu, of course, that would automatically include the space, and I'll just put in some digits, just a few more, just for fun. So to do a random binomial, we can just go to our menu, once again to probability, choose random and binomial. And random binomial, if I just put in, say, something like 11, comma, 0.6, so basically that's my n value, the number of trials I'm going to do, and the probability of success is 0.6, so there's a value there. If I want to get a sequence of them, I will just put in here the number of repeats I want to do with that. So what I'm going to do now is I'm actually going to store that. So control var will give me the store. I want to store that as a list. If I had to put this into the formula line in the list and spreadsheet, then, and I gave a list name at the top, it would do the same thing. So I'm just going to call this list 1. And now that is stored as list 1. So I can now go and do a plot of that, and Rodney did some plots of just some random generated numbers. So I'll just insert a data statistics page, click here, list 1. So there's your dot plot. Now if I did quite a few of those, I'm actually going to do some interesting things here. I'm actually going to take this now and I'm going to change this to 200. And now I'm going to go back and have a look at this plot. Very interesting, you'll notice that this plot is very, very close to a normal distribution. And a lot of people will look at this and say, oh, but the probability was 0.6. This is not the probability values, these are actual numbers generated. So they're not the probability distribution. So it's not a binomial probability distribution. So it is a normal distribution, and this is how we would do our sampling of means, exactly the same way. So if we go back here, that's N, that is P. NP generates our means. So that's the theoretical measuring of the mean. So 11 multiplied by 0.6 will give us our pretty good close, or a guess to our mean. So I'm going to do a normal distribution here, but I'm actually going to change this from a dot plot into a histogram. And the reason why I'm going to do it as a histogram is because I now have another option. I can go up here to Analyze, and I now have something called Show Normal PDF. Now we can only do this with univariate numerical, and it must be in a histogram form. You can't do it in a in a dot plot form. So there it is there. So the interesting thing about this is that we have the mean and we have a standard deviation there. So if I actually went back and multiplied this 11 multiplied by 0.6, we should come very, very close to this mean of the normal distribution. So it doesn't matter what sort of distribution we've got. If we're taking a sample of the means, a distribution of the means, then it will come out basically as a normal distribution. The more samples we have in it, the tighter this will be, the less spread. In other words, the standard deviation, which is referred to as the standard error, will be less. So that's just that little bit of information there, and I'm now going to just take that back, and I'll just go into here again, and I'll just remove this. Analyze. I just want to hide that one there. I'm actually going to change this back to a dot plot. It doesn't have to be back to a dot plot. I'm going to have a look at something else that a lot of people ask about here under our plot type. They ask, what is that fourth one, the normal probability plot? Well, basically, it's a test of normality, so I'm going to do this. It'd be nice to actually run this with your class, wouldn't it? To test how much normality you've got in your class. But when we look at that, we can see that that's a very, very good fit. But if you look at that regression equation, this is the mean and this is the standard deviation. And it should ring bells to teachers, x minus mu over sigma is your standardized Z value. So that's normal probability. You can see the expected Z. It automatically labels it over here. So if you're doing normal distributions, and of course doing what we did there, even though it was a random binomial, it was generating a normal distribution, as will all means that you generate from samples will approach a normal distribution with the same mean or p-value if you're doing proportions as the original population. And we'll just leave that one there. We've got about 6 more minutes, and I'll just go back and we'll just have a look at sampling. So that was random binomial, and random integer is done much the same way. And by the way, if you're not sure what the syntax for each of those is, what you can do is on your calculator where the book is, make sure you're in column 1, which is your catalogue, and if you type in R, don't type in anymore, you've now got to go for a search. If you choose, say, Rand's norm, it gives you the syntax along the bottom. So you need to put in your mean, your standard deviation, and optional is the number of trials that you want to do. In other words, that's your sequence, how many you want to produce. So if you're not sure when you're using your calculator about what syntax you've got to put in, particularly if they don't have little boxes for you to fill in, then just go to that catalogue, make sure you're in column 1, and just go and choose the one that you want. So this one here, if we just go back to that one again, and our sampling distributions. This is new on some of the courses. The Australian curriculum, the national curriculum, has introduced it as well. Some states have always used this. In Victoria, we used to have it in something called R&D, Reasoning and Data. It is now coming back in on board. So how do we actually work it out? So I'm actually going to go past this one and just go down to proportions first, because our time is running out. This one here, we're going to just do our proportions, sampling proportions, which is probably the most important. It's called p hat, is your sample proportion. So basically, if you've got a population, it will have some statistic there, the probability or a parameter, which will be the proportion. So you might have, say, people going to supermarket A and supermarket B, and there might be, say, 0.65 of the population, 65% of the population always go to supermarket A, and you're going to take a huge group of people, and you're going to take, say, 20 samples and find out what proportion go to each. And then you're going to plot those answers, and that is called a sampling distribution. In this case, a proportion. We could do it as a mean, or we can do it as a proportion. Generally, what you'll be asked to do in the courses now is a proportion. So the way that I would suggest we do, once again, I'm scrolling through here. This is a nice little way of actually doing it here. I've just made some random numbers. So if I just call it alt sampling, I'll just call this one up just before we finish. We've only got a few minutes left. And what I've done here, this one here, I've just called that random normal 1, and this one here is random binomial. And because our proportions are based on binomial, either yes, they're going to this one, or no, they're going to that one. So the proportion is, the p-value is basically a success. So NP that we can use. So in this example here, I've used a random binomial. 10 is the number of trials. 0.35 is the number of probability of success. So that's a population proportion, which is just normal p. And 50 is the number of trials. And I've just created that. I've copied this and put it in this formula and generated them, put it into this one, and I've done 5 of those. So there's 5 of them, and then I've just taken the mean of all of those. So that's just doing the mean, and then I've plotted that mean. So that's the mean, so that's sampling distribution of the mean. And once again, you can see it is approximating a normal distribution. So if I now go to this one here, I'm actually going to now just go into proportions. So once again, I'm just going to generate exactly the same things, random binomial in this case here. Oops, cancel this one. So I'm just doing random binomial, 10, that's n, that's the p, 50 trials, and I'm dividing by the number of, or the value of n. This brings it back to a proportion. So over here, I'm now creating all the proportions and getting the average of the proportions. And then I'll just go through and plot that, and that's the proportion of those. Now, the only reason why I've done it this way, and it's not the way I would normally do it, but a lot of teachers and a lot of students don't want to believe that just one column is going to basically give you the same result. So I've gone through here and we've got a mean of the proportions. So I've just added these up. So I did 5 trials, 5 separate trials, added them up. And you can see that it will give me this normal distribution. So just to finish off, Peter,
yeah,
this is the way that I would do it here, is basically just going to do it as, and if we just call this one up, and so there's just an example. We'll put those on the web. So basically all I would be doing is this. So the question here was, we know the people in Australia have 55% of people in Australia have blue eyes. That should be just a normal P. I was just testing you there. And we're interested in the values of the sample proportion, which is P hat, which might be observed when samples of size 100 are drawn at random from a population. Well, this does follow binomial. They've either got blue eyes or they haven't. So rather than repeating half a dozen columns and adding them up and getting the mean, I can just do one column. The random binomial, which you just get from your menu, data, and random binomial, so you can get it from there. 100 is the number of people, number of trials that I'm doing. That can be any value. This is the population proportion, and this is the number of times I've repeated. So I've taken 200 samples. So 200 samples of that, NPs, 200 of those, and divided by 100, which is dividing by n. So there they are there, and all I'm going to do is plot that, and you can see it's a normal distribution, and there is the mean, and there's the standard deviation. So that's the new topic for a lot of you. It's called sampling distributions. It will mainly be sampling distributions of proportion, P hat. Well, I think our time is up, Peter, so I'll pass it back to you.
Yep, certainly. Thanks, Russell. And just while we're waiting for my computer screen to come up, I am familiar with a different P hat. I have a particularly nasty possum that resides at the front yard where our rubbish bins are, and unless I have the P hat on, it's likely to get me. So, apologies for that really bad joke, but that's what I'm good at. Well, some people might argue I'm not so good at those jokes. All right, so just before we go, a quick reminder that there are some conferences coming up. We had a little PowerPoint slideshow at the start of the webinar showing that there's a MASA conference coming up in April, and the Tasmanian Mass Conference in May, and QAMT in June. Hopefully I've got those dates correct, Rodney?
That's correct, yes, the Saturday and Sunday.
I did good, thank you. And the other thing I wanted to show people is we have an Australian curriculum website which has some of these data and statistics things on there. There's a new section on our web page where teachers can click on, and if they click on here, and it'll take them straight to a teacher resource section, and they can go under here for professional development, teacher resources, activities, and so on. They'll also notice that they can go straight to the Australian curriculum website in that drop-down list, and we might want to have a look in Year 10, and we'll have a look what we've got for statistics and probability, and you'll see there's some activities. We could do interpretation. There's one on the FIFA World Cup. These ones here are fairly new. These ones are assessment tools. So, for example, this one's on quartiles and interquartile range test. That was just put up the other day. And you can click on there and have a closer look at the activity. It's done as a TI-Nspire file and also as a PDF. So if you didn't want to use Navigator, which will automatically correct these pieces of work for you, then you can download it as a PDF, photocopy it and give it to your students. And of course we're also kind enough to go ahead and put the answers in there for you as well. So it's usually 2 pages or a single piece of paper, double-sided, and you can see it specifically addressing the Australian curriculum, statistics, probability, standard 248, and we're looking at, as it said there, quartiles, interquartile ranges, and medians, and so on. And all those, of course, are free. So that pretty much brings us to out of time. I'd like to thank everybody for coming along to our webinar today. I know there's a lot of schools, and my daughter's school included, which had parent-teacher interviews. So if you've come from parent-teacher interviews and managed to join us, then we certainly appreciate the fact that you've done that, given the heavy load that that puts on teachers. And if so, then you better go and get your dinner. Okay, thanks Rodney, and thank you Russell, and hopefully we'll catch most of you on our next webinar.